Testing, testing. Are we live? Checking to see if we're live. Always gotta check to see if we're live. That's how you do it. Let me see. So come over here. Let's do content. This reminds me of if anyone watches like the Joe Rogan Experience. Previously, when he used to go live, that's how he would start. He'd be like 3, 2, 1. We're live. I think we're live now. Yep, we're live. All right. Yes, we are live. Oh, that's awesome. Look at that. Sugoi waiting. First one here. Welcome, Sugoi. Welcome. Hope I'm saying your name right, Sugoi. But really, really happy to have you here today. That's awesome. Always great seeing a familiar face. Do I have any housekeeping to do? I don't think so. I think everything's pretty good. Happy Friday to everyone. Looking forward to this weekend. I'm going to be watching the movie Nope tomorrow from Jordan Peele. If you've seen it, don't spoil it. I'm excited for that. I'm going to go on a nice date. It's going to be cool. So I'm excited for that tomorrow. It should be fun. And without further ado, is that how you say it? Further or do? Maybe, maybe not. We're going to go and start off with some LeetCode. As you all know, just for anyone new that's watching, so my intent is to go through every single LeetCode question, starting from the easiest, then medium, then hard. And so far, if you started with me, we started doing these streams on the 16th of July. And ever since then, I've been doing at least one daily, which I think is pretty awesome. If you have stuck around with me since then, we're currently sitting at 94 questions complete. So we've made a ton of progress, and we're going to continue making some good progress. So let's see. We know that we are modifying this, not modifying it, sorting it by acceptance. And we're going to start at the second page, just like we did yesterday, just from where we left off. So let's start with this one. Count negative numbers in a sorted matrix. So given m by n matrix grid, which is sorted in non-increasing order, both row-wise and column-wise, return the number of negative numbers in grid. So let me see if we start. I'm going to be moving my mic a little bit here, so apologies if it makes any noise. If I start, again, I'm always going to start with like drawing this out. So let's say we have 4, 3, 2, -1. We also have 3, 2, 1, -1. We also have 1, 1, -1, -2, and then finally -1, -1, -2, -3. Okay, so let's think about this. This is going from highest to lowest, right? So, I mean, we could obviously, I feel like a brute force method would be to iterate over every single element here and just count every single one that's negative. But if the negative one is not even in one of these arrays, like if both of these never have negative values, we would just be maybe traversing them mindlessly. I don't know if that's like the best way, but maybe instead of going from left to right, since the left can be like a really high positive number, whereas if we start at the end of it, it could just be negative already. Maybe we can just start reading it like we know at some point we're going to get to the positive, right? And that's when we can automatically go to the next row. So we can say, let's see, while the row is less than the last one, and then we can set the column to be the row.length -1. We can start counting backwards and say, okay, this is 1. This is positive, so just break. Don't even continue processing the whole thing. Let's go to the next row, and so on and so forth until we sort of get to the end of that. So let's say that we have let row equals 0. We can say while row is less than grid.length. Here we can say let column equals grid at row.length -1. And let's also say let, that will be like our row. I'm just going to sort of move this here. Let row equals 0. I'll have a negative variable up here. So negatives equals 0. And what is it that we want to do now, right? We want to say while column is greater than or equal to 0, if, right? So if grid at row column And something that we can do here, we can use this method on the math object called sign. So if math.sign at the current sort of cell, if that's equal to -1, it's a negative number. So math.sign equals -1. Here we can say negatives plus plus. So if we do negatives plus plus, else we just break, right? Because if we break, that means that we're at a positive, so we can just break that loop. So let me just try to run this immediately and see what we get. Are we, oh, obviously we are not, let's see, this is always going to be, we need to increment this to row plus plus. That's the part that we missed there. Classic mistake. Are we also not, while column is greater than or equal to 0, of course we're not also decrementing column. So I made the same mistake twice there. Look at that. It's the first question. We're just warming up right now. 8 and 8, use example test cases. See what we get, 8 and 0, 8 and 0. Let me run this and see what we get. 74.37, pretty happy about that. So what is it that we did here, right? Because I drew it out, I mean, your first idea, the first thing that you might think is, I'm just going to go through every single cell. But like we saw, there's a chance that only the last number can be negative and not, like only the last number is negative, everything else is positive. So you still have to traverse the entire row just to be able to figure out that it's negative. Or worst case, you go through the entire row and nothing's negative. So you just wasted all that time. So what we do here is, since we know it's always going to be sorted in decreasing order, we start at the end and we only ever count just the negatives. So, I mean, it could be, would this even be row, like we would have to go through every row. So it would be M, I guess like M would be the row, but column, the N would just be the amount of negative numbers, which also it could be all negatives. Now is this, it's always going to be the same. So would this still be quadratic? I'm very, very curious. And maybe there's even a faster way of doing this. Maybe we can do, I mean, one optimization I can make is that if the first one is negative, then I just add the length of the current row. So we can do if, let's see, if column, what if we do something like if grid at row 0 is less than 0, then we can just do negatives plus or equals grid at row dot length. If grid dot row, we can do this, else maybe here we can sort of put this while loop in there. Did I, this is this, that's like that. We'll put this back. Negatives, this goes there. Where does that one belong? So I've kind of, if, let me put some curly braces. Just gonna make it easier for me to read this. So what am I doing here, right? If the first one, like let column equals grid row length, but if we say if grid at this row, if the 0th position is less than -0, we can just return the length minus 1 actually. Or no, actually we still want to return the length. We want to return the length of this, right? Because all of them are going to be negative. Negatives, else we can just do this whole thing, column minus minus, and let me see, this one goes there. So do we need this one? This is the else. Oh, there you go. This belongs there. That belongs there. This belongs here. Row return negatives. Let's see what this gives us. 8080. 76.89. So that's another sort of like optimization we made just by realizing that we don't even need to do anything. Like if these are all negative, I'll still traverse the entire array, but I can get from a linear time solution to just constant time by saying check the first index, that's constant, and then just get the length of this, and we can just add that to negatives, and that's that. So if we submit this again, just trying to see how our solution stacks up here. I'm pretty happy with the times that we're getting here. So yeah, let's move on. Return the robot to origin. I'm going to be checking something throughout the time that I'm here. There's a very important email that I'm waiting on, so apologies if I stop talking for a second. That's fine. We can go back now. So there's a robot starting at the position 0, 0, the origin, on a 2D plane. Given a sequence of its moves, judge if this robot ends up at 0, 0 after it completes its moves. You're given a string moves that represents the move sequence of the robot, where moves of I represents its ith move. Valid moves are R right, L left, U up, and D down. Return true if the robot returns to the origin after it finishes all of its moves, or false otherwise. The way that the robot is facing is irrelevant. Okay, so what if we had sort of like coordinates, right, that represent the origin? Or maybe we can just say let origin equals x0, y, or let's just say point. Point equals x0, y of 0. Now we're going to go through each one of our different moves, right? We know what each one of these represents. So we can almost say for const m of moves, here we're going to have a move. For each one of these, we want to do something. Like if m equals to u, what is it that we want to do? So if we go up on a 2D plane, like Cartesian coordinates, then we know we're increasing the y, right? So we can say point.y plus or equals to 1. If m is equal to right, we can say point.x plus or equals to 1. If m is equal to down, then we can say point.y minus equal 1. Put u equals -1, d equals, yeah, exactly. That's pretty much exactly what we're going to do. If m equals up, right, down, left, we can do point.x minus equals 1. And then at the end, we can just say return point.x is equal to 0 and point.y is equal to 0, right? Because if we do up and down, so let's say we go up, point.y plus or equals 1, then we get to d, point.y minus equals to 1, they're both equal to 0. If we have L is going to subtract -1, so I'll be -1 here, and then another one -2. Add them all. If they were at 0, then we're at the origin. Oh, so instead of even having like this sort of like object literal, we can just have like a counter. Yeah, we can definitely do that. Let's do both of these real quick. That's actually a great thing to consider. Up -1, down +1, L -2, R +2. Yeah, I guess each one of them can represent something different. Let's see. Now, would that be the case if I go left and right? Oh, so you always want ones that cancel. So what if let point equals 0? If it's up, we can just do plus or equals 1. If it's down, we can do minus or equals to 1. If it's right, we can do plus or equals to 2. And if it's left, we can do minus equals 2, right? And then we can just say return point equals to 0. Let's try this out. True and true. Feeling good about it. Ooh. Up, down, down. Add them all. If they are 0, then we're at the origin, right? Left and right, because these should cancel out. Left is minus equals 2. Right is plus or equals 2. Maybe that just starts getting into some... Because I guess maybe that's not how... Maybe because that's not how the coordinate system works, it makes them this a little bit weird. Because it makes sort of sense, right? Like if this... We just always put the opposite of the direction it's in, and that way we'll know we're back at 0. But yeah, plus or equals 1, minus equals to 1, plus or equals 2, minus equals to 2. Return point equals 0. Yeah, it seems like it didn't like that, but I'm sure there's probably a way to solve it that way, because that really does make sense to me. Let's continue on here. Okay, let's see. Let's look up the solution here. Simulation x0, y0. Right, moves that count equals cleanest r left ud. Bar I and moves, storage R equals storage L, and storage U equals storage. Yeah, I guess that's pretty clean, very clever. That's nice. Cool, let's continue on here. Counting bits. Given an integer n, return an array answer of length n+1 such that for each I number of the binary representation. Oh, this one is difficult. I'm going to have a standing desk. I'm going to put it on sitting mode. So just bear with me for a second. It's going to make some noise. All right. Yeah, I've been standing up for a while, so. All right. Yeah, this count bits one. This used to be like the first medium question if you sorted in terms of acceptance. So I'm convinced that this is, I'm going to save this one because I've tried to solve this one and I haven't been able to, but I really want to, but I need to sort of like spend some time on my own thinking about it before I come on here and talk a little bit about it. That way I can give you guys, like, because I feel like this is such a high quality question, I want to be able to provide a really great explanation as to how I came up with it. So I might table it for now, but we can certainly return to it later. Let's do height checker. Okay, so a school is trying to take an annual photo of all the students. The students are asked to stand in a single file line in non-decreasing order by height. Let this ordering be represented by the integer array expected, where expected I is the expected height of the ith student in line. You are given an integer array heights representing the current order that the students are standing in. Each height I is the height of the ith student in line, 0 indexed. Turn the number of indices where height I not equal to expected. Didn't we, why do I feel like we've already solved this one before? Huh, okay. So 114213 and expected is 111234. This seems a lot like another question. Like I almost feel like my first inclination would be to sort, like create a new copy of heights, sort it, and then just compare the indices each way. But I almost feel like this is definitely going to be counting sort. It's bounded by 100. I can just count however many we have. Yeah, let's think about this. I think what we can do is we can create const counts equals new array of 101, right? Because I think we're going to be going, yeah, all the way up to 100. So we'll make it 101. And we're going to fill this up with 0. Let me see if we can sort of think about this, right? We have like, let's say we have an array of 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have, or we can just have this one, right? We don't need anything special here. So like I know I have 3 1s. So let's say in the first place here I put 3. I have 3 1s, 1 1 1. I have 1 2. I have 1 3, and I have 1 4. So maybe what I can do is I can loop through my counts, and let's say I get to like, let's say I have one pointer here, I, and then I have another pointer for my counts, j. Like this is 0, so I don't count it. Then I go to j equals 1, and this tells me that I need to have 3 1s. So I can say like while this number is greater than 0, I can say, okay, is I equal to the current one? Yes. Go up by 1 and decrease this by 2. Right? I is 1. Yes. Go up by 1, decrease this by 2. Now here we can say I equal, we'll still need one more, but it's not the same. So we can still make this 0. Now we have not same equals 1, and then we increase this. Now, now I go to the next one here. Let's see, this should be a 2. Right, I have 1 2, and it should be a 2. So that's fine. So continue. And this is used up. I have 1 3. So this should be a 3, which is not. So that's not the same. This becomes a 0, and we continue. Now this should be a 4. I think I meant to put 1 here, but it's not. So continue, 3. So this is like something I'm thinking about doing, because ultimately we just need to create it based on the frequencies, and I want this to be ordered, which this array can help me out with. Now let's see how we can sort of like put this into code. And I'm sorry, I'm going to check my email again. Nice. Okay, I got a response that I was hoping, which is awesome. Okay, so let's see if we can like fill this up, right? Let's do for, or we can do, yeah, const h of heights. We can do counts at h plus or equals 1, right? So it'll just create the frequency for me. Now, what is it that I want to do? Can I sort of set, maybe I can set like let height index equals 0. And I'll say let counts index equals 0. While counts index is less than counts.length. Do I need to go through, maybe I can just go through all, I guess I'll just go through all my heights because we're always incrementing the height. So while height index is less than heights, what can we do here? So we need to first find the first place where counts index is not 0. So we can say while, but is that making it, I get to the first non-zero position, right? Because I need to find the index of the first thing that's non-zero, like for let I, or maybe we can just say counts index, or counts at counts index, let's see, equals to 0, count index plus plus. Or maybe we can just, instead of doing this, we can say, while counts at counts index is equal to 0, we can say counts index plus plus. So suppose now we're at an index in our counts array that represents the frequency at that index, right? So we had 0, 1, because we had 3 ones. So now count index should be 3. That's a 3. So what do we do now? Now we start comparing. Here we can say let not same equals 0. Here I can say while counts at counts index is greater than 0 if, let's see, if the heights at height index is not equal to the current counts index, then we do not same plus plus. We do counts at counts index, or we can just do, yeah, counts at counts index minus equals to 1, and height index plus or equals 1. I kind of want to like go through a drawing of this because I realize this is maybe a little bit confusing. So we have 0, 0, 0, 0, 0, 0. We have 3 1, so in the 1 index we put 3. We have 1 2, so 1 2, 1 3, and 1 4. 1 4. Right? Let's say here we have, this is going to be my height index, and this is going to be my count index. So while height index is less than heights, which it is, heights.length, here we say while counts index equals 0, we go up here, and this should be counts index. Here we can say while counts index equals 0, this is false, so now we continue. While counts at counts index is greater than or equal to 0, if heights at height index, which is 0, that's a 1, is not equal to count index, not same plus plus. That's fine. They're both equal, right? The C1 and H1 are the same. So now we put this at 2 and we increase height index. So while counts at counts index is greater than 0, which it is, if heights at height index, so heights at height index 1, that's also a 1, not equal to 1, not same, that's fine. We now reduce this again, right? So we reduce this. Height index goes to the next one. If heights at height index is not equal to counts index 1, not same now equals 1, right? Because 1 is not equal to 4. counts index minus equals 1. This will be a 0, and now we'll go to the next thing. Okay, cool. While counts at counts index is greater than 0, it's not, so we start the whole thing over. Height index less than heights.length, yes it is. While counts at counts index equals to 0, so now we increment this. We get to the next spot. If counts at counts index is greater than 0, okay, now we compare. We have 1, 2, and this is in the correct position, so we don't do anything. We decrement this, and we increment this. Now we start again. Okay, it's equal to 0. Yep, so we continue up here. Are these the same? So count index is 3. This is 1. I think we were supposed to increment it before, so now this is 3. Make this a 0. Go to the next one. Now we increment this again because it's 0. While counts at counts index is greater than 0, which it is, if heights at height index 3, 0, 1, 2, 3, not same. Oh, I think we didn't have to do that. Now we would do not same. We increase height index. We modify this here, and now this is out of bounds, so we can return not same. Return not same. So let's see how this goes. Const h of heights, counts plus plus. All right. Will this work out for us? 6 and 3. Interesting. Why are we doing this more times than we have to? 1, 1, 1, 4, 2, 1, 3. Okay. Sure. Well, I'm a fresher, so I may be wrong, but won't it be easier if we check first element of the array is greater than the second index? Then the n is the answer as we're all arranged incorrectly. I don't know if it's so much of like figuring out if we're arranged correctly. Like this is just some, I mean, it should be arranged in increasing order. I was thinking like one thing we definitely could do is we can just sort the input array and then count the indexes that don't match. That's one thing I was thinking. I'm not sure if I understand too much of what you mean. Check first element of the array. If it's greater than the second index, then we know we're incorrectly organized. And then n is the answer. I'm not sure, but perhaps. I mean, I can certainly look into it. I'm going to go over this one again because I really felt like we had something here. So array 101. So let's say, again, we're just filling this up with all these for const h of. We're supposed to get the output in the answer. I'm thinking on those lines. Output in the answer. I'm thinking on those lines. Yeah, we can explore that in one moment here. I think, is there like maybe another way that you can explain it? I'm just a little bit confused. But I really do want to try out your solution though, because I'm always open to seeing like how others solve problems here. What I'm trying to implement here was like, I was trying to implement counting sort. I was able to think from example 2 perspective where output is 5. Oh yeah. Yeah, that's like something where like this is one of those contrived examples where you can sort of think like you're locked into this one way of thinking like, oh, if it's just greater than that one, then we can just return the result. This is one of those things I've had to work on myself because it's sort of easy to lock yourself into like one method of thinking, but in reality, it's like something else. So, but I'm glad that like, I think what you're telling me is like, oh, maybe I was just thinking about example 2, but I didn't think of like example 1. So I've definitely been there before. I totally get what you mean. So let's go over this one more time because I think it's worth exploring here. So we have count index 0, height index is 0, right? So while height index is less than heights.length, that's fine. While counts, oh, we still have to do this, right? For const h of heights, counts of 1 plus or equals 1. So that should all be the same. Console.log counts. Let me just do a console log of my counts here. I feel like this should be giving us, unless maybe I'm just doing that piece wrong. Yeah, 3, 1, 1, 1. Okay. Pretty much what we got before. 0, 3, 1, 1, 1. Okay. So while counts at counts index, while counts at 0, which is 0, equals to 0, we increase this. So now while counts at counts index, which is 1, is equal to 0, which is not, so now we just stop this. Now, while counts at counts index is greater than 0, which it is, if heights at 0 is not equal to 1, right? Because counts index is 1, then not same is plus plus, but they are equal, right? Because height at 0 is equal to c, which is 0. So now we do counts at 1 minus equals to 1. This becomes a 2, and then we increase the h here. While counts at 1, which is this, is greater than 0, which it is, if heights at height index, which is 1, not equal to 1, which it is, that's fine. We subtract another one here, and we increase h. Now we say, well, again, while counts is greater than 0, which it is, if heights at height index, which is now 0, 1, 2, 4, not equal to 1, not same, plus plus. We remove one here, and we increase height index. Height index is still less than heights.length. And we can say, well, counts at 1 is equal to 0. We do plus plus here. While counts at 2 equals to 0. No, it's not. Okay, we get to the next one. Remember, not same was 1 from the previous one. If heights at height index not equal to counts index, they do. So we decrease this. We increase this. This is 0. We increase this. Now we're here at c, right? Here at c, it's greater than 0 if heights of height index, which is 1, is not equal to 0, 1, 2, 3, not same, plus plus 2. Counts at counts index minus equals to 1. Height index plus or equals 1. This is now 0, so we increase. While counts, okay. If heights at height index 3 is not equal to c, which is 4, not same, plus plus, this is 3. Height index plus or equals to 1. All right, counts at counts index, okay. While height index is less than height's length, it's not, so we return not the same. So why would we get a 6? This is like where a debugger would come in very helpful. Oh, wait. Okay. We definitely got 6 last time. No? Oh, I think not same. I had set to 3. 3 and 5, 3, 5, 0. I think I had actually changed not same, 31.94. So is this even faster? Let's try out a couple different things. I mean, you can sort of think of this as linear, like we're not having to do an n log n solution, but like it might be n by m. That is super slow, right? It does seem super slow. I just sorted and compared. Nice. Got 74%. Yeah, well, again, I'm happy that like I was able to do this way. I mean, I feel like because this counting sort of thing sort of comes up a lot where you use some auxiliary storage to count frequencies of arrays. Yeah, it's slower for sure, right? Let's do that. And by the way, so go ahead. Did you also do it in JavaScript? I forget if you're the one that was talking about JavaScript earlier. I'm very curious to know. I can also do it myself too. Java, okay. Let me see. Let me do sorted heights equals heights dot sort a minus b, and then we can say we can also do, let's see, I can do return heights dot reduce, or maybe sorted heights. We can do return sorted heights dot reduce act val, and then we can get the index here. So if sorted heights, and we can say original array r, right? Like if r at index is not equal to heights of index, return act plus 1 return act plus 0. Here we'll put a 0. Let's see if this works. 353500. All right. I mean, well, let's keep running some and see what we get here. Use this to share code. Oh, like you want me to share my code? 43.47, 96. So the two, 93, 93. Only one of them ran faster with my other solution. Okay, this one was 85.84. So let's sort of like backtrack here, right? Like this, the exercise we just went through is like, this is exactly what the point of this live stream is. I think it's phenomenal. Like we explored two different methods of solving the same question, and we, because the community like getting like involved here, we're able to sort of come up with two different solutions. So this first one here uses the quicksort algorithm, and it just compares each of the indices, right? So this is just bound by quicksort, so it's n log n, and then really the only space is the copy that I have to make of my array to sort it, which I believe would just be n. And then for the time complexity on this one, like the space is constant here. I'm only ever using a static array, but the time, it does. The counting bits question is very interesting. The time here I think would be like, I guess like m by however many numbers there are, however many, like the frequency of each one, like almost m by f or something like this. We go through counts, which I guess would just be static. Do we even consider that? We go n by f, something like this. That's how I would sort of rate this in time complexity. But yeah, really happy with this question. I think we did good on that one. So let's get to this next one here. All right, the Hamming distance between two integers is the number of positions at which the corresponding bits are different. Given two integers, x and y, return the Hamming distance between them. So I think there's like, I feel like there's a very simple way of solving this maybe. Let me see something. We have 0, 0, 1 and 0, 1, 0, 0. If we do like an exclusive OR, we'll always make it that it's a 1 when these are different. Wait, so does that just give us the 0, 1, 0, 1? And what's the relationship between this? Oh, wait, the output's 2? Oh, okay, 2 places. And then how many ones are toggled after that? Can we do like the XOR of the numbers and then see how many bits are set? Let's see. There's sort of a trick to this. In the sense of like, I think the trick is if you do n and n minus 1, or maybe, yeah, I think if we do that, then that will count the amount of zeros there are. So if we do, or the amount of ones. So this is 1, 2, 4, this is 5. So let's say we have like, okay, there's 0 ones that are set, right? Let's say 0 ones that are set. N and n minus 1 will be 4. So this will be our 4. So what are we left if we AND these together? We have a 0, 1, 0, 0. And then we do n and n minus 1. And then that operation is 1. And then n and 3 would be 0, 0, 1, 1. If we AND all this, we'll be just left with 0. And that operation is 2. And then we just have 2. I forgot the name of that formula. It's just something that I've learned, and I think you should all learn it as well. It's the ability to count how many set bits there are in a number. So I think what I want to do here is almost like XOR, do an XOR of x and y, and then count how many set bits there are in the result of that. So we can say let XOR equals x XOR y, and then we can say distance equals 0. While XOR is not equal to 0, we can say, or I think I can just do, while x, I guess, yeah, while XOR and XOR minus 1, let's see, is not equal to XOR and XOR minus 1 is not equal to 0. Distance plus plus. Return distance. Whoa, I messed up my cursor there. Return distance. Is this something that we can do? I think that might work. Maybe. It didn't like what I did here. Well, XOR and XOR minus 1 is not equal to 0. Distance plus plus return distance. XOR is X, XOR Y. Let me see something. If I do 4 and 3, let me just like open up my DevTools here. Let's go to console. So if we do 1 and 4, let XOR equals 1 or 4. XOR is 5. XOR and XOR minus 1 is 4. Or let's do XOR equals XOR, okay. And then this, that's 0. So can we just do, maybe I should just remove that whole thing and just have this distance plus plus. Maybe some like weird logic in there messed up. That also doesn't work, huh? Oh. Do I need... Yeah, wait a second. I'm only doing the comparison, but I'm not like setting it after I do the operation, right? One and 2, okay. Well, XOR and XOR minus 1, distance plus plus, XOR equals XOR and XOR minus 1. Or did it already set it once there? I wish we can see output even if the time exceeded. It's not entirely clear to me why that wouldn't work. XOR and XOR minus 1. Distance plus plus, and then we do XOR equals XOR and XOR minus 1. Because that's essentially what we just did here. Or maybe we should just say, well, XOR is not equal to 0. Distance plus plus. Two and 2. Here we got 2 and 1. Okay. 91.42. There you go. Yeah, this, I forgot the name of this. Maybe this is just like Hamming weight. Maybe it's the Hamming weight. Hamming weight is a string of symbols that are different. Okay, this is something else. What is how is Hamming weight? Number of set bits in its, yeah. Calculate the Hamming weight. Hamming weight of an array is a sum of Hamming weights of all numbers of 1. Number of set bits in its binary representation. So this formula of the n and n minus 1 allows us to calculate the amount of set bits. So to be able to get the number of where these bits differ, we can think of XOR. The reason we use XOR is because if you draw out a truth table of XOR, like we can just draw one here, we have 0, 0, 0, 1, 1, 0, and 1, 1. XOR only gives 1 when it's exclusively OR, right? So when they're different. So that's how you know, like if the bits are set after doing an XOR, or rather doing XOR on two numbers will give you the set bits of where they're set, if that makes any sense. And then we can just figure out the Hamming weight of that. So yeah, interesting question. I think Hamming weight is just one of those things that you sort of need to know. I wish there was a better way of explaining it. I feel like obviously something else you can do is if you know, like here is 230 or 2 to the power of 31 minus 1. You also could just write a loop that goes 32 times and then just use bitwise manipulations to check for a set bit, and that should also give you the same result. But I think this one's a little more elegant if you know it. All right. Whoa. Replace elements with greatest element on right side. Ooh, okay. Classic monotonic stack. Perhaps. I keep thinking it's monotonic stack, but now that I'm looking at this, it's actually not monotonic stack. right? We can write this out because I have done this one before, but imagine that we have, like, what is the max we can have? The max is -1. That, like, to start off with. The greatest element among the elements to its right. So the greatest element to its right will just be whatever max is. So max here is -1. So we set this equal to -1. Then we come here and we say what's greater, 6 or -1? It's 6. Now our max becomes 6. What's greater here, 6 or 4? It's 6. 6 or 5 is 6. What's greater, 18 or 6 is 18. And then at the end, I guess at the end we're just, it's because we need to also, yeah. But I remember thinking that there was like a nicer way of doing this. 6 is 1. What's greater, or you just always take the max. If I'm sitting at 1 currently, if I'm here at I say max is, take the max, okay, that's -1. Set the new max, that's 1. So set nums I equals to max, which is -1. And I think we can say like new max equals to nums of I equals max, max equals new max. I think we can do this and just go all the way back. Just to confirm, I need to know about XOR Hamming weight. That's it for such questions, or are there any other things which I should also learn? I think like that's a phenomenal question. I think bitwise manipulation, and it's sort of been the same for me, is I've never like really studied it. I've never taken too much time to look too deeply into it. I just approach it based on the first occurrence of such a question that I see. So when I saw that Hamming distance question before, I was like, maybe I should know about Hamming distance. I should know about Hamming weight. I should understand XOR. That sort of got me into this rabbit hole. In a good rabbit hole, I was like, oh, okay, like this is, now I start learning about all these different bitwise operators and how they work, and I start experimenting with them. I say experiment because it's very important that you like open up your own code editor and write out these operations on your own to understand how they work. A lot of times you'll see me write out the binary representation of these numbers because it just helps me sort of like work through it in my head. All right. So I'm going to sort of approach it from this way here. So let's do for let I equals r dot length minus 1, I greater than or equal to 0, I minus minus. I think here I can say let max equals -1. I can say new max is equal to nums of I. Nums of I equals to max, and max equals new max. Return nums, or return R. I always do that where I like, I'm so used to seeing nums or R for an array. That's just like how I think about it. Might not be taken into account. Yeah, okay. That's there's one more thing I need to be doing here. So if we have 17, 18, all this stuff, we can set max. Maybe this instead should be math.max of new max, or the current max. And then perhaps in here, this will just pick the greater number. Yeah, there you go. So I just have to make one small change here, because I was always taking max to be, or new max just to be the element that's at the array, but there might actually be a better candidate. And by better candidate, I mean a higher number, if that makes sense. So let's submit this. 64.31. So yeah, this is pretty good. This is going to be linear time complexity with constant space complexity. We're only having to traverse the array once from the end, going all the way to the beginning. And then it doesn't matter the size of our input array. We're always going to have just this single max variable. So that makes for a nice algorithm. Yeah, these are the best, right? Like linear time and constant space. That's a beautiful thing. Don't get that too often. All right, maximum units on a truck. All right, nice. This looks like it's going to be a high quality question. You were assigned to put some amount of boxes onto one truck. You were given a 2D array box types, where box types of I equals number of boxes and number of units per box. Number of boxes is the number of boxes of type I. Number of units per box is the number of units in each box of the type I. Okay, wait. Number of boxes of type I. The number of units in each box. Okay, I see. You're also given an integer truck size, which is the maximum number of boxes that can be put on the truck. You can choose any boxes to put on the truck as long as the number of boxes does not exceed truck size. Okay, there's one box of the first type that contains 3 units, 2 boxes of the second type that contain 2 units each, 3 boxes of the third type that contain 1 unit each. You can take all the boxes of the first and second types and 1 box of the third type. Do you always want to take, like, because this is just like a I think this is just, if we have 1 and 3, 2 and 2, and then 3 and 1, we want to fit, what is it? Maximum total number of units that can be put on the truck. We can put 3 1s, we can put 1 3, or we can put 2 2s. Truck size is 10. You can put 91. I feel like maybe this second solution or second example here might be better. So 5 and 10, 2 and 5, 4 and 7, and 3 and 9. Just getting some water. So this is the number of boxes and the units. We can put 5 boxes of 10 units each, 2 boxes of 5 units each. Is 50 plus 10, 60 plus 28. So how do we get to 91? And the truck size, you can choose any boxes to put on the truck as long as the number of boxes does not exceed truck size. So how do we know? Interesting. Give me one moment. I'm just going to send a quick text message. Okay. How should we figure this question out? You can choose any boxes to put on the truck as long as the number of boxes does not exceed truck size. If I'm trying to figure this out like as a human, like let's just say someone asked you this question without you ever having like there's no coding involved. Just how would you know the most amount of boxes that you can store if I have 10? Like if I do 10 of 5, that's 50. But there's actually we can do better, because 10 of 5, but then we can do 7 of 4, 9 of 3. If I do 10 of 5, do I maybe want to build it up from the bottom up? Like, do I always just take the least? Total number of units that can be put on a truck. 5, 7, 9. I have this 10. Again, it can't be like, you might just say, oh, we have the truck size is 10 and I have exactly 10 here, but then that's just going to give me 50. But apparently we can get 91. Because there might be boxes. Let me see. This is amount of boxes. Right? This is number of boxes that each have 7 units. Five and a 4. That will give me a 9. What if I just always take, wait a second. What's 50? 50 plus 27. That'll give me 8. And then I take 2. Wait, like maybe we just always take the largest ones. Like we have 5 of 10, right? Because 10 is however many. Oh, but Like, are the units this? Number of boxes, number of units. Well, let me see if this math works anyway. We have like the 5 plus 10, so we take all 5. And then the next largest one is 9, so we take all 3 because that's 8. Next largest one is 7, so we only take 2, and that's 14. This would give us 81, which is just 10 shy of the answer, I think. Right? Did I not do this? No, wait a second. That's 11, right? So 6 plus 7, yeah. Should be number of boxes doesn't exceed truck size. Yeah, I think what we can do here, like let's think about this. I like this question. This is a good question. Like the first thing I want to do is I almost think like I can sort this. I think maybe we should use the greedy approach. Yeah, no, that's exactly what I'm thinking here. And I feel like this, I feel like it shouldn't be units because we just did the math here. Well, let's prove it the other way. It should be 8 here, right? And I have truck size of 4. So I'm going to look for the thing that has the highest like number on the right. So it's 3. So I add 1, 3. So that gives me just 3, right? And now I have truck size of 3 left. The next largest one is 2. I can take both 2s because I still have 3, and that'll give me 4. That'll give me another 4. And then I can only take 1, 1, right? I have 3 1s, but I can only take one of them. So that gives me 1. So 1 plus 4 plus 3 is 8. So I think that's what it is. I think what I'm going to do is I'm going to sort it. I'm going to sort it by the second parameter here. That's what I'm going to do. Yeah, that's what I'm going to do. So let's look at this. So let's do truck size and box types. Let's do const sorted box types equals. Let's do box types dot sort. I want this to be in decreasing order. So box types sort. I'm going to open this up to make it a little bit easier to read here. We'll do box 1 and box 2, and we'll return box 2 at position 1 minus box 1 at position 1. And let's just like log this out to make sure we're getting the right thing here. Let's see what we got. So 3, 2, 1, right? So what we can say is like we know the amount of box types that we have. So I think what we should just do is while truck size, we can say let maximum equals 0. While truck size is greater than 0. Let's see. Or actually, I can just say for const box of sorted box types. And inside of here, yeah. Here I can say const, and I could do the similar thing here where this is num boxes and num units equals box. Box. I'm going to let this actually be let and not const because I'm going to be modifying this. So how is our array working, right? We're going to look at the one that has the most, and we can compare it with the truck size. Like we always want to take, can we just always take the difference of, so like here we have 10. Say I have 10 left, is 5 less than the amount I have? Or let me just try and take like the current truck size minus the amount that we have. Okay, that's 5. So minus 5, let's say that's 5. Then I look at the next one. Let me sort this myself. That way it's just like easier because this is exactly how it's going to look. Let's do 3, 9. Let's remove this. And we'll put our 4, 7. I know it's just looking a little bit weird, but this is how it would be sorted, right? So we come here and we say, okay, I have 5, that's fine. So I'm going to add all 5 of them, and I'm going to multiply that by 10. So 5 times 10, now we have like 50 here. Now I get to the next one. I have 5 left. Can I put all 3? Yes, I can. So we'll do 5 minus 3. That leaves us with 2 left. But now we add 27 to our number. We do this. We get to the next one. Can I add, is the amount that I have greater, or the truck size I have is 2. If it's less, we just add the difference, pretty much like 4 and 2, right? So that'll just give us 2. 2 times 7 is 14, and that gives us the final answer. But I want to see if I can sort of use that difference equation. That way I don't have to like have logic for like if it's lower or less. What's the difference of 10 and 5? That's 5. What's the difference of 5 and 3? That's 2. That becomes a new one. Difference of 2 and 2, that's that. So I think we can do that. Okay. So for const box of sorted box types, if truck size less than or equal to 0, we can break. Else, what do we want to do? We want to get the difference. So let's say const difference equals math.abs of truck size minus number of boxes. All right, number of boxes. We're going to multiply that by the difference. So we can say maximum plus or equals the difference times the amount of units. And then we can say truck size minus equals the difference. So then we come the next time, right? So now truck size is 5. We get to this point. We see the difference of truck size and num boxes is, oh, the difference is 2, but we want 3, right? We want to take all 3 of them. I don't want it just to be the difference. That would work in that case, but I mean, can we always just do, what if I always just subtract? Yeah, if I get 5 minus the difference would be 2. Or take however many I can get up to the truck size. So I have 4. If it's greater, well, let's think about this, right? Num units is either going to be greater. Num units will be greater than truck size, or num units will be less than or equal to truck size. So let's sort of like view it. I think we need to view it like this. Here I can say if num units is less than or equal to truck size, then we can just take all of them, right? We can just say the difference is, maybe instead of the difference here, math.abs minus truck size, but maybe instead of that, we can just do the difference. We can say truck size minus num boxes times num of units, and truck size minus equals num boxes. Let's do this, else it's greater, and if num units is greater, or not num units, I'm sorry, if num, no, this needs to be num boxes. Num boxes, truck size minus num boxes times num units. Okay, num boxes. Else if num boxes is greater, then we just take the difference from, maybe here, we can do maximum plus or equals the, let's see, the difference between these, right? We can do math.abs, or we can do maximum is equal to num boxes minus truck size times num units, because this will just be 2 times the amount of units, which is 7. And then we can say truck size minus or equals that difference. It's a little bit of a, I think, repetition here. Maybe I can get away from doing, because I think there's definitely like a much easier equation for that piece right there. I'm making that a little more complicated than it needs to be. So if truck size, I really just want to draw this out one more time so we can really, and this time I just want to draw it out a little more neatly. Let's just do 5 and 10. Let's just do it like this for now. It's fine. Let's do this. We have 5, 10, then we'll have a 3 and a 9. We'll have a 4 and a 7. Okay, let's go through this. Truck size is 10. If truck size is less than or equal to 0, we break. Now, if the num of boxes, 5, is less than or equal to truck size, so that's fine because we can put all of them. We can say maximum is equal to the truck size. No, we should just take all of these, right? If it's less than or equal to, then we can just take all of them. So it should just be maximum plus or equals num boxes times num units. We can take all 50. Right, num boxes times num units. And then truck size minus equals the nums boxes. Okay, that's fine. So now we get to 5 and we're visiting the next one. If num boxes 3 is less than or equal to truck size, we just take all of them. Num of boxes times num units. Great. Then we do truck size minus num boxes. That's 2. If num boxes 4 is less than or equal to, no, it's not. So now the maximum, and maybe here I can just get the difference, because I do want to get that difference, equals num boxes minus truck size. So 4 minus 2, and then we'll just add the difference times the amount of units. And then we just say truck size minus equals difference. And then at the end, we'll get here 2 times 5. Now we subtract 0. If it's less than or equal to 0, we break, and we can return our maximum. So let's see if this works. Return maximum. Let's run this. Ooh, 1 away. I want to do both real quick. Is it 1 for both? 9 and 91 and 8 and 91. Let's see. What would this one be? It's going to be some edge case here that maybe we didn't consider. I think this is already sorted in the way, and I almost feel like they did that on purpose. That's something to take note of. Like if you look at the input, they gave it to us sorted in the way that would make it easier on purpose, I feel like. Right? Because we're sorting by the number of units here. So let's see. Truck size is 4. We get to the beginning. So if the num of boxes is less than or equal to truck size, maximum is equal to num of boxes 1 times 3. So maximum is equal to 3. Truck size minus 1. Okay, that's 3. We get to the next one. If num of boxes is less than or equal to the truck size, which it is, we can just take num of boxes 2 times 2. So we add, oh wait. Oh no, that's fine. We add 4 to get 7. Okay, sweet. So we get to the next one, and then we also subtract 2 here, which is just 1. So now truck size less than or equal to 0. No, if num of boxes 3 is not, so the difference is num of boxes minus truck size. Maybe we just take the remainder that we have left. Do we just take truck size amount? Because this means that num boxes is greater, right? So can we just take however many we have left? Like maximum is just truck size minus num units. And then we just do truck size minus equal to truck size. That's like kind of weird. But I guess this would necessarily be the end. Let's see, difference. I don't think we need difference here. Maximum is just going to be the truck size 1 times 1. I'll add the 8 here. And now we can just subtract truck size equals, like minus equals truck size. I've never seen that before, like x minus equals x, but perhaps that's okay. Let's see how this would work. $891. Okay, so if we submit this, wow, 80.34. Awesome. Yeah, this question was really cool. Like, I have not, and the cool thing is we sort of like made it a little bit easier. Is there anything that we're doing the same here? Num of boxes or num of boxes? I'm super glad for this stream. I had given up on algos and DS a while ago, but now I can see that it's okay to not understand right away and keep working slowly and get the answer. Thank you. I gave up halfway. Yeah, absolutely. Like to both your comments, like the point about, if you think about, like, this is, there's a lot I can say, right? The reason that I am doing this stream this way, because like I said, there's plenty of resources that you can go and you can look for the solution, and someone will explain this to you in the most optimal way. They'll probably explain some thought process behind it. But the thing that I feel like you miss out on is, for example, like me struggling through it. I would hope that with this stream, because you're hearing the things that I'm thinking about, the mistakes that I'm making, you can, everything that I'm considering, the trade-offs, that would hopefully give you some more insight into the problem and hopefully teach you the sort of things that maybe you can be thinking about. And yeah, it definitely takes time sometimes, but now hopefully the next time we see something like this, we can identify it right away, right? And I think probably in total this took us like 15 minutes maybe 20, I would say, for an easy question. And remember, this is a high-level easy question, so I would expect for it to take longer than maybe some other ones. I'm going to add this one to my list. 20-25 minutes for an easy question, I think it's okay. So I gave up halfway. Hey, no worries. That's why we're here doing this together. So like, I would encourage you, I added it to my list, Rafael Negron's list. So I would encourage you to go back to it and see if you can figure it out. I think this was a really great question. Again, this is bounded by quicksort, right? This is an n log n operation here. And over here, we just iterate through our array once. And the time complexity, it's just a constant. I believe that quicksort has like an internal quicksort space complexity. The in-place version of quicksort has a space complexity of log n, even in the worst case. The unstable partition requires O of 1 space. Let me see. So, I mean, if you want to consider the internal stack frames of quicksort, you might want to mention to your interviewer, hey, I know this is going to take up a log of n internal stack space, so we can consider that too. But a lot of times they don't consider internal as being part of the space complexity, so you might just be able to get away saying that it was constant. I'm going to have some more water here. All right, I'm a little bit over my stream, but it's Friday, having a good time. Tomorrow, I'm going to be doing a stream tomorrow, but I'm going to do it earlier. It might actually benefit, I don't know if it was Segoy or Rashawn. I think it's like a 12-hour difference between you and I. So I'm going to plan on doing mine tomorrow, probably like by 11 in the morning. So it'll be late, 11 p.m. or maybe 10, but we'll see, because I have plans in the afternoon, so let's do that. Cool. Let's get to the next one here. Maybe I'll do like one more, and we'll go from there. Or actually, I want to hit 100. Let's see how many we've hit. We were at 94. I'm sure we've done at least 6 100 questions. So milestone number 1. We're like we're only barely a sixth of the way through, right? But we hit 100 questions on LeetCode, which is pretty amazing. So thank you so much to everyone that stuck around. Again, if you've like followed with me all the way, and remember, like just as a quick note, right? You're on my channel, you're watching this. Let's say you're like, oh, I want to start from, like the first video ever. You can start right here in the accountability stream.
I did have like a premium account as of
right, and this like, if you start here, you'll be able to start all the way in the introduction. You can go through every single question. The funny thing is, in this video, I didn't even have a good mic set up, so you're gonna be hearing whatever audio, and you can see I still had like the white background. So we've evolved since then. I've had a lot of fun doing this. But you can follow me all the way from the beginning, and that's something you can do, right? You can like open tabs for all these questions that we cover, and then you can solve them first and then watch the video, or just watch the video as I'm doing your you can watch the video as you're doing the questions. That's my girlfriend letting me know that she's hungry. So we're gonna do one more, babe, and then we'll get there. But thank you so much for the support. I love seeing it. Tell your friends at work. One more, because I already had the tab open, so I gotta do one more, right? Everyone in the community, yeah, let's do one more question. All right, let's do it. One more question. Let's see. It might be easy. Check if number has equal digit count and digit value. So we're given a 0 index string num of length n consisting of digits. Return true if for every index I in the range of 0 less than or equal to I less than or n, digit I occurs num I times in num, otherwise return false. Okay, so the digit 0 occurs once in num. 1, 2, 1, 0. The digit 1, okay, 0, 2, 1, 3, 1. The condition holds true for every index in 1, 2, 1, 0, so return true. Occurs twice in num. 3. Okay, so I think I can create like an index. I can get a frequency of this, right? So let's say I had 1 appears twice, 2 appears once, and 0 appears once. And then I can loop through this and say 0. Oh, 0 should map to it here. Like the digit 0 occurs once in num. Okay. Digit 1 occurs twice. Wait, what? Oh, okay. Digit 0 occurs once. Digit 1 occurs twice. Digit 2 occurs once. And digit 3. Okay. I feel like we definitely need a map here. But num being of digits, we can really just make an array that's of size 11, and we can fit everything that way. So let's say like const num counts equals new array of size 11 dot fill 0. Good night, fellas. Hello, ma'am. Sorry to keep him away and you hungry. He's seriously hopping a lot. We request a little more patience in the most respectful ways. I'm gonna go sleep at 6 a.m. and I didn't sleep whole night. I'll catch this question later. Good night, fellas. Thank you so much for joining, Sugoi, and thank you, Barcott. Yeah, let's get it. Let's do one more question and we'll go and eat. Const num counts. So let's do for const n of nums. What do I need to do, right? I need to increment, like for each one of these, I need to parse the num first. So let's say parse num equals parse int of num, parse int n, and we'll take 10 here. Parse int is the right one, right? I don't know why it's not being highlighted, but that's okay. And then we can say num counts at parsed num plus or equals 1. And now I think all we need to do, can I do every on a string? String every mdn. Array prototype every. Okay, I guess we can just loop through this. We can say for const for let I equals 0, I less than num dot length I plus plus. So the digit 0 should occur 0 times. So let's see here. Digit 0 occurs once in num. So if I is not equal to num counts of I, return false. Else return true. I think this is what it's doing. Let me see that the digit 1 occurs twice. Oh, and it should also map. Oh no, it should be if num of I, if num at I not equal to num counts of I, at num counts of I, I'm just putting an integer. Okay, this is just like hard to read. It's a little bit confusing, but let's see. So 0, we want it to appear once because it's the first thing here. and I already kept track of this, and I know my key is a string. So the value of the thing at 1 should equal the digit 0 occurs once in num. So let me see. Num counts at I needs to equal num at I. The digit 0, which is I equals 0, num of counts as 0 is 1, equals this one. Now, I'm gonna take advantage of loose equality here because I'm storing this as a number, but I'm comparing it against a string. If I do strict equality, it's gonna try and compare a string to a number, which will always be false. But if I do loose equality, there'll be some type coercion, so we can sort of handle that. For const n of nums, oh, I don't even know why or how. This should be num. Let's do this. True and true. True and false. Submit. 83.73. Beautiful. Awesome. Yeah, I love it. It's awesome. Again, we used a static filled array here, so this is just constant space. We're not using any other space here, so it's a constant space algorithm. And then as far as time complexity goes, we have to loop through so we're looping through num once, and then we're looping through it twice. So it's 2n, we drop the constant 2, we end up with a linear time algorithm with a constant space algorithm. So yeah, really happy to have done this question. That's gonna leave us at 101 questions, which is crazy. I mean, we've made a ton of progress in about 14 days, 13 days. We've done 101 questions which I think is a lot. At this rate, right? Let's imagine we want to get to 600 questions. So for every 14 days, we do 100. So 14 times 6. Let me just do that real quick. 14 times 6. 84. It'll take us about 84 days, probably a little bit less. Let's say like 75 to 84, which ends up being maybe like 2.5 months to be able to do all the easy questions. So we're in this for the long haul. And I promise you, I'll be around every step of the way for everyone that's following. So thanks again so much to everyone that tuned in. I feel like I'm getting real close to my mic here. Thanks so much for everyone that tuned in. I'm really happy to have gone through all this. Really happy that we had a lot of audience participation today. Looking forward to continuing working through all these questions with you all. And have a great weekend. Have a great night or morning. And happy coding. And see you all tomorrow. I'll post the stream information as soon as I get up. Later, guys.